Okay, welcome to this YouTube lecture. We are going to discuss about how to find limits of the indeterminate form infinity minus infinity. We'll use this example for illustration. So in this case here, solution, the first thing is to test for this indeterminate form. So this is the same as limit as x approaches 0 of 1 over sine x minus limit as x approaches 0 of 1 over x. Now the direct substitution should tell you that now 1 this is the same as this first limit, sine of 0 is 0, so it's like we have 1 over 0 minus, here is also 0. So 1 over 0 is infinity, 1 over 0 is also infinity. So this is the case of infinity over infinity. So then now what we do, we try to see whether we can write this function in a form which will allow us to have either infinity over infinity or 0 over 0 case to allow us to apply L'Hospital rule. So the function that we have is 1 over sine x minus 1 over x. So let's try to put the two functions together. So the LCM will be x times sine of x, and then this into the LCM will be x. This one to the LCM is minus x. So that now we have limit as x approaches 0 of 1 over sine x minus 1 over x is the same as limit as x approaches 0 of x minus sine x over x sine x. And then let's try to see now, because now we have now f over g, let's try to see whether when you do direct substitution, we'll have a form that will allow us to apply L'Hospital's rule. So when you put 0, we'll have 0 minus sine of 0 over 0 times sine of 0. 0 minus 0 is 0, 0 times 0 is 0. So therefore, this is the case of 0 over 0 case. So therefore, L'Hospital rule will work. So therefore, limit as x approaches 0 of 1 over sine x minus 1 over x will be, now we differentiate this function. So x approaching 0, 1 minus cos x. This one we use product rule because they are two product of two functions, x and sine x. So u prime is 1, so sine x, plus v prime is cos x times x will be x cosine of x. And then let's try to see whether this time round we have the answer. So we have 1 minus cos of 0 over sine of 0 plus 0 cos of 0. So 1 minus cos 0 is 1 minus 1. 0 plus 0 times cos 0 is 0. So this is 0 over 0. So we have 0 over 0 case. So we still reapply L'Hospital's rule, because this is still an indeterminate form which is respecting the hypothesis of the L'Hospital's rule. So applying the L'Hospital rule again, so the derivative of the numerator will be sine of x over, this will be cos of x, and then x, we use quotient rule, a product rule here, so it'll be plus x, let this one to be u, this one to be v. U prime is 1, v prime minus sine x times x, so we have minus x sine x. So remember, this is cos of x, so this is cos of x. So therefore now we have the same as limit as x approaches 0 of now cos x plus cos x is 2x, 2 cos x, and then minus x sin x. Now let's now substitute in the values of the limits. So we'll have sine of 0 over 2 cos of 0 minus 0 times sine of 0. Sine 0 is 0. Cos of 0 is 1. 1 times 2 is 2. 0 times sine of 0 is 0. So this gives us a good number because we'll have 0 over 2, which is defined as 0. So therefore, the given limit, limit as x approaches 0 of 1 over sine x minus 1 over x is nothing but 0. So that is how we evaluate it. Good. So do as many examples as possible the same.